Hello everyone, welcome to Zoom in Data. In this DP 600 course, you'll learn Microsoft Fabric from an analytics engineer's perspective, focusing on data modeling, DAX, performance optimization, governance, and building end-to-end analytics solutions. This series is designed to help you prepare for the interview while gaining practical, real-world skills. At Zoom in Data, we simplify complex data concepts through clear, structured learning to help you grow faster in your data career. Measures and calculated columns are two fundamental concepts in DAX used to perform calculations in a data model. Measures are dynamic calculations that are evaluated at query time based on the filter context. In contrast, calculated columns are computed during data load and stored physically in the table. Understanding the difference between them is critical for building efficient and scalable Power BI models. Measures are calculations that are evaluated dynamically when a user interacts with a report. They depend on the filter context created by visuals, slicers, and report-level filters. Measures are not stored in memory, but are calculated on demand. They are commonly used for aggregations such as SUM, count, average, and ratios. Calculated columns are computed row by row during data refresh and are stored physically in the table. They operate in row context rather than filter context. Once created, their values remain fixed until the data is refreshed again. They are often used for creating new columns such as categories, flags, or derived attributes. The key difference between measures and calculated columns is how and when they are calculated. Measures are dynamic and evaluated at query time, while calculated columns are static after data refresh. Measures use filter context, whereas calculated columns use row context. Measures do not increase model size, but calculated columns consume memory because they are stored physically. From a performance perspective, measures are generally more efficient because they are calculated only when needed. Calculated columns, on the other hand, increase memory usage since they are stored in the model. Large datasets with many calculated columns can also slow down refresh times. Therefore, choosing the right approach is critical for optimizing performance. Measures should be used for aggregations such as total sales, averages, and percentages. They are ideal for dynamic calculations that change based on filters applied in reports. Measures are commonly used in dashboards and interactive reports. They are also suitable for KPI calculations and business metrics. Calculated columns are best used for row-level transformations and derived fields. They are ideal for creating categories, labels, or flags. They are useful when values need to be stored and reused across multiple visuals. Calculated columns are also often used in defining relationships and improving data modeling. Measures rely on filter context for their calculations, meaning their results change based on filters applied in the report. Calculated columns rely on row context during computation, meaning each row is processed independently. Context plays a crucial role in determining how values are calculated and displayed. Understanding context is key to choosing between measures and calculated columns. Measures do not consume additional storage in the data model because they are calculated dynamically. Calculated columns, however, increase the model size since their values are stored physically. Having a large number of calculated columns can negatively impact performance. Efficient data modeling requires minimizing unnecessary columns. As a best practice, you should prefer measures over calculated columns for aggregations. Use calculated columns only when necessary for row-level logic. Keep your data model optimized by reducing unnecessary columns. Always consider performance and scalability when designing your models. To summarize, measures are dynamic, efficient, and context-driven calculations, while calculated columns are static, stored, and based on row-level logic. Choosing the right approach helps improve performance and scalability. Understanding both concepts is essential for effective Power BI data modeling. Thank you for watching this video. Stay connected and contact Zoomin Data for more content on Microsoft Fabric and DP600. At Zoomin Data, we focus on clear, practical learning to build job-ready data skills. Follow Zoomin Data for the full series and more insights.